Hello, everyone, and welcome to the broadcast. I see Code Fortune has joined us. Welcome, welcome. Hey there, Tass. I spent a good portion of time, folks, getting the collision shader closer. I shall speak to you of memory layout shortly. But welcome, everyone. Welcome, Tass, Code, Key, anybody that might be lurking at any point. It is a coding day, but before we get too much further into it, let's see where the kitties are. We have Sky up in the tree, Molly next to the mouse. We have Mason and Sammy on the bed. Sherbet going over to get a snack. No, he thought better of it. He was watching TV. Oh, hello, Sherbet. Hello, buddy. Are you passing through? Are you here for back scratches? Or both? Ember was on my shoulder and has disengaged now. I moved the canvas further over because Ember likes the different texture options. She hopped down because Sherbet was encroaching on her personal space. Oh, but hello, everyone. Let me show you the thing I was working on between the last code stream and this one. As you may recall, I was trying to get kind of a hacky version in place, and we got some of the start of it, but there was still a lot not working. It is now mostly working. We've got some magic strings in here. I'm going to want to put this somewhere else. The shaders in general and whatnot, I want to get into the cataloging system so that we can find them. But nonetheless. Okay. So here we go. This is the size of our shader collider data structure. We're using memory marshalling here to say, how big is this thing? And now we have a array of bytes, which is our data that will house the shader collider structures. A buffer for it. This is our testing collection here. We'll get rid of you. Part of what we should be getting to today is whatever this structure is going to look like. It shall be fiddly. And then a buffer for it. When we initially start up, we are going to create our initial shader. We're going to allocate our bytes. Now, we're doing that in the ready because we have this variable here. Could I do all of that here? Yeah. But it will be useful to have this later. We make our buffers. We subscribe to our events. So we're interested in game start step, the top of the Godot physics loop-ish. Because that's when we're going to check we're going to get our data from the shader. We're waiting a whole other tick. This is actually akin to what Godot already does. In its physics calculation, we're just doing a hopefully faster but scarier version. And we're watching for when entities are added and when the world steps are done. When the world steps are done, and this is a new final step, not the world end step, like the official end of round, in a card game. This is, we're complete with all steps. This should be just a listen for it and wrap up. This should not be a do things that others might depend on. Kind of a finish up your work, finish up the remainder of your work kind of thing. So this is when the shader will kick off. start step. So if we are doing shader work, we are going to sync the device. The reason that we're waiting until this point, and only if we're computing, is that this is not free if you do it too often. In fact, it's not free if you do it at the wrong time. This is, hey, graphics card, sync up with the CPU a moment. And we want to do that very infrequently because the graphics card can be all super speedy and whatnot compared to the CPU in a lot of things. So if we're constantly telling it, hey, wait, come over here, it's going to lose a lot of that. We are going to extract the data from the buffer. This is our output test buffer currently. So where we're expecting to put the data, we dump that out. Then we are saying this span, this predefined area of memory is equal to this data treated as a float. What this should be doing is not having to copy it over into a float array. We still have to get it locally and say, this is the memory that we're getting, the array that it is outputting. This is another reason. So the GPU is waiting until it's done. We are saying like, okay, hook up and then wait until we get all of this data. Or as much data as we tell it to get, but we want all of it right now. We could async this, but that delays our physics processing further. That is, we could have it like periodically say, get me the first X, get me the first X. But we don't want the physics process to sit and wait ultimately, and we don't want the simulation to take extra physics steps. But we get our result without duplicating the array. We will then do stuff. Hey there, Alkaline. Welcome raiders from Alkaline. Oh, a whole bunch of folks from Alkaline. Welcome, everybody. You are arriving in the start. I'm describing our shader workflow here. We're doing a tricky thing. Welcome, everyone. So, we get our data. This is where we are going to do a thing. So this is... We're going to put that there. What were you folks up to, Owl? We will call out physics are done, and then we're cleaning up. We're saying we're done computing, we're done with this pipeline, we're done with this data set. We might be able to have some of these linger. We just have to be careful about that. But for the time being, we're purging them out each time. Ooh. Eventually I'll get some streaming integrations into this, but that's I'm done with everything else step. Most of the events on my stream are tied to some scripting. I would like to get them tied into some more web services and the like. Well, not web services, but WebSocket kind of stuff. So that I can have more precise control without having to fiddle with StreamerBot's scripting interface. Would I like to have my own integration? Yes, but I don't know that I want to take the time to wrangle the YouTube stuff, let alone figure out how to do the OBS and such. Yeah. I had set up back in the day when we played Noida as our primary thing, I had modified the Twitch integration in that I had shimmed that event, but also pulled in data. I kind of jerry-rigged it in from StreamerBot into a WebSocket into into a text file, which could then be loaded as a ad hoc script into Noida that could then work with the existing Twitch integration, so that the YouTube folks could cause mayhem as well. Jank as all get out is the best way I can describe it. Okay. We were trying to do this as an async callback in, but I couldn't figure out how to make that work. It would be kind of nice. A simple WebSocket-driven extension for Twitch integration. Two things happened. Lost the source code and Twitch discontinued the server it was pulling from. Yeah. Noida in the integration I did, the way it did Twitch was actually just string parsing. Because everything that happens in Twitch chat is actually like coded text. It doesn't matter if it's bits or a channel point kind of thing. There's sort of a text syntax for it. And it's a IRC feed, so that's Twitch integration is so much easier. That's why most games have Twitch and not like YouTube. Because YouTube is a whole thing. All right, so when the world step is done, yeah, I get that feeling, Thrax. You had something and it was working, and then something breaks it, and it's a huge setback. Whether you lost something and have to start over or similar, and it just sort of drains the momentum out of you. Though sometimes it can end up being the other way around, where it is sort of a surge in that you had been dragging your feet because you had built up a layer of tech debt, All of this stuff works, but it was expedient at the time or in hindsight. But you didn't want to take the time to redo it, but you still want to finish it. And the fact that it completely exploded and is gone now is kind of an excuse to remake it. Semi-related, I have remade this code so many times. This particular section is actually a remake of some code that used to exist. Ground up. So we build our collisions, we're making our pipeline, we're feeding our uniforms. Hey, casemate. Yeah. I mean, this whole game dev project is something like that. I started, I put my foot in the door with game dev before, and then I would just not actually follow through, not go in the room. But this time I'm a do it. If by no other means than pure obstinance. Create our uniform, begin our compute list, and then we tell the graphics card go. Collision Thrax, let's see, we started out this whole project in GD script. And I didn't like a lot of the things that GD script kind of pushes you to do. It was largely just get used to it. Then I started shifting over to C#, and we have been through physics server, then Godot nodes, then really overly clever physics server stuff, then a shader, then back to Godot nodes, then back to physics server, and now back to shader. We are trying to tighten performance so much in this game because I want to have big numbers, big numbers. We will have the biggest numbers, the best numbers. So we launched that. We are going to come back around to some of this in a moment. Okay, so I shall show you the thing that was like a whole day of head wall intersection here. This structure. So shaders are real particular about memory layout when you give them things. You are essentially handing them a box and saying, I promise it looks like this. But it's not like the shader code knows what you're talking about. You're just saying, it looks like this box. And there are, as far as the shader is concerned, boxes have rules. And if you don't match those rules, the box won't be right. You know, it will get it and it will say, oh, the contents of this box are different. And currently, at least as far as it's like OpenGL shader language, GLSL. It works in 4-byte chunks. So, 4-byte memory size. So if you use something smaller than that, it's actually 4 bytes. And you need to account, it's actually 4 bytes. And there are particular objects, particular types of data that actually get counted as larger than that. Vectors are one of those things. Doesn't matter if it's a vector 2, 3, or 4, it gets allocated the sort of space that goes to a vector 4. And it wants it to be in chunks of vector 4. So the what is it, like 16 bytes or something to that effect. Yeah. So you want your stuff in units of 16 bytes. So previously, this vector 2 was right about here. It was above collidable, this Boolean, and that's another 4-byte thing. And I thought, well, okay, it's there, and that means I can put category and mask beneath it, and that will be another 4 bytes. So it was here. So 4 bytes, 2 bytes, vector 2, 2 bytes. I'm sorry, 16, and then 8 because 2 floats, and then 8 more because 2 uints, same size. Cool. And then there would be some dangling memory at the end that it would just pad out, which should be okay. But it's not, because this is not 8 bytes. This is actually 16, and there's some space here. And if you don't account for that space properly, bad things happen. So to solve my problem, to keep this data from being all byte scrambled, it has to go down here. And there's this little uint that does nothing to say, this is space right here. Don't use this space. Now I could do layout kind, it's like explicit, where I tell it, this is at byte 0, this is at byte 16, kind of thing, and like socket them, which could let you do things like cram the vector in alongside two of them. And that's not terrible because I'm dealing with things like there's about 20,000 of these. Yes, Thrax, because if you don't, the layout of the memory is off. So every time you try to reference it, the bits are going to be in the wrong spots as far as what the data, where you think the data is. So you get gibberish out of most of it. Yeah, layout explicit lets you say the order of them, but that's real fragile if you get it wrong. And we define our interface. That's all nice. Data copying stuff. Like, for example, here, a shader collider circle, when we load it in, so that is part of shaders. So as far as the graphics card is concerned, now Godot has a little bit of its own spin on these, like this compute directive at the top is a Godot thing. But the rest of this is all in like effectively in C kind of era. And then on top of that, the data that's coming into the GPU interprets it. So I'm telling the GPU, here's a lump of bytes. And then the GPU gets it and says, okay, I'm going to get a lump of bytes, and this is the shape of it. So again, that little padding value there. As far as the GPU is concerned, if this doesn't line up to those 16-byte chunks, it will pad them out. So there's like there's like 12 bytes dangling off of the end of this that the shader is going to handle for us. It needn't, but it shall. So then we define them. We say I have a whole array of them of an arbitrary length. Then we're going to go through the whole collection. Let's, for those folks that can't see it, that'll probably help a little bit. It's not going to do much for the people in tall format, but there we are. So we're figuring out like how many of them are there. We are breaking down the work groups and local work groups into an index. So under this pattern, we are breaking it up. Let me find it. Searching. Here we go. So as far as our shader, we've got 4 groups that have 4 groups that have 64 groups. So we have our 1024, effectively our max size. So that's 20,000 objects broken into 1,024 segments. Then we get into the shader, and we have another set of segments. We have 20 groups of those segments. I could break it down further. But at the moment, we're not gonna. So each one of those work groups is responsible for 20 values. So this 20 happens in the code sequentially, synchronously here. The rest of them are split up amongst the... they're handled asynchronously on the GPU. So we're going through and we're saying like, okay, break this down into chunks here. So every X is 256, every Y is 64, and every Z is a single unit. So Z is 0 through 63, that increments Y. Y is 0 through 255, that increments X when it goes up. So we have a very weird base of counting going on. And then we add our local invocation ID X, which will give us our exact index here, which one of the shader bits structs we're looking at. Some hacky code in here right now. We double check that the index is less than the data size. If I change the data size over in the other code, I need to change this shader. I could compute this myself. I could remove this X, but we'll have to deal with that. So what this shader does is it takes one of these structures, which tells me the shape of it and then a few dimensions of it. Could I have more dimensions? Absolutely. That would change the structure size. But anyway, we then have category and mask, which is what this thing is and what it collides with. And then whether I should care or not. So assuming it's a valid index, we're going to check and see, does it collide? If it doesn't, we're going to skip it. Then we're going to iterate over everything that wouldn't have been checked yet. So every structure after that one is now going to be checked against this one. We're going to see if it collides with that one or that one collides with it. By checking the mask against the category. If it does, we are going to put that in the output. Exactly how? That's fiddly. I'm also going to have to look up at some point in this stream. There is a way to have effectively an access lock that says you have to only one entity is allowed to touch this this data value at a time. We need to be careful with that because that can mess up the asynchronous processing. But if we are careful about it, then it won't really matter too much. Or it shouldn't matter too much. Because while there can be this can account for 20,000 entities in the world, 20,000 bullets, monsters, whatever. It is unlikely that they're all bumping into each other at once, creating contention for particular slots. So we have a crude kind of collision here, where we're saying this is how far apart these two things are. Absolute value of the difference between the two positions. This is assuming a circle, a set of circles. Hey there, Laura. I'm describing what the shader do. Then if this distance is less than, I think I've got it less than or equal to the sum of the radii of the circles, then that's a collision. This is part of what wouldn't work right now, or that there is a potential collision in how this functions. Because it's technically possible two of them try to access this data at once, and at the time of indexing, if both of them see that this number is 2, they're both going to set it to 3 instead of one going 3 and the other going 4. So the end result of this should be a series of effectively integers. And what we'll do is we go through that collection and find which one we're dealing with. So we find the index, so it's index 5 is entity 5. And then we're going to go through a list from that. So this is a compute shader. In general, shaders are like the initial implementation of them, and the most common form are graphical shaders. So like a layer of processing over top of a texture to fiddle with it kind of stuff. Compute shader is one that's run ad hoc. I define it and I execute it, and then it's done, and I get a value from the buffers. So it's not really part of the rendering chain here. The reason that we're doing the collision here is that calculation handled elsewhere in the engine is relatively expensive and doesn't happen exactly where I want it to. So in Godot terms, the default physics is done using bodies of various type. The body is a kind of a class suffix. So you have like static bodies and what are they? Character bodies, those kind of things. And those have built-in physics simulation. There's gravity and friction and all of that. And the Godot physics process handles that for you. And that's not fast, and it's definitely not built for like 5,000 things flying around. It is absolutely not built for like 5,000 things. We tried it. Oh, Super Earth. Operation Valid Pretext. The robots stole our plans for our definitely not a Death Star. We need to stop them before they make a Death Star. So the body-based physics won't work for us. We had been using area-based physics. And areas are, it's just space with a shape. And it detects when there are overlaps. So it's not doing these two things bumped into each other and stopped or slid along each other kind of physics. Areas are just saying these two bubbles overlap. But because our simulation is not using the Godot generic simulation, it is using our own, this is how things move in this very particular way. We have to do areas, and we have to set their position. We don't say move in the Godot physics world and under its rules. We say move exactly here. But changing the position directly of an object inside the physics code does not necessarily update it immediately in the Godot simulation. So you can have in the code say this entity has moved 10 steps to the right. And then the next step, the next physics step says, hey, 10 steps to the left, this thing bumped into something. But as of that check, it shouldn't have been there. So that was our biggest problem. We would get we would get a second false collision. And that's not good. So this part is essentially saying, okay, well, forget all of that. We'll do it ourselves. And we're going to leverage the GPU to do it because GPU is speedy. I think it will run right now. Eventually that loading screen will actually do something. The presence of these shaders is actually going to be part of what will make it do something, because we will be using other shaders, more compute shaders and some texture shaders. Okay, so I have it limited to 120 frames per second right now, just to control that. So no actual collision is happening, but if we pause for a moment, We are going to go into our collision manager here, and we are going to do our on game start step right here. Stop. Okay, so as of that moment, as of right now, the shader just got done. And we've got our result collection here. This is 20,000 floats. Now, something is clearly wrong here. As in, we're not getting all of the results we should in this 105 territory here. But all of these numbers are correct. These teeny tiny float numbers are effectively how many values are below this. So this one never gets any sort of calculation on it because every other entry has already checked the last one. And this is happening every other frame. We are iterating over the whole mess. So for stress test purposes, we are going to create 3 to the 6th entities per second. Now, it's not counting entities because I don't have one of the updates properly in place. Okay, so this is just emitting them. We're not doing the actual a collision happened right now, but we're sitting at 30 frames per second as far as visual frames. But our physics frames are slowing down here. We will need to be looking at this and how to tune it properly. I will need to... Because we are getting... the entity positions aren't updating at the right moments. But you can see the, like, 1. So we're getting a lot of graphics frames, but we're not getting world simulation frames happening. But that's kind of okay. At 3 to the 5th per second, lasting for about 10 seconds each. At any given time... No, I'm sorry. Yeah, 3 to the 5th. So let's see here. Over 2,000, maybe 2,500. Let's make them do interesting things. Yeah, the burst pattern isn't working how it's supposed to right now. But again, that's okay. We'll be revisiting that stuff. Yeah, this is operating at 3 to the 5th. We're still getting full simulation frames right now. And we are getting solid graphics frames. Yes. There is a lot happening. Somewhere in our game... I think it's in game that updates. Services screen. Okay. Okay, update debug doesn't seem to be happening. No, some of the update debug is definitely happening. It's the entity manager, and entity manager should be a base entity manager, which is currently still up here. Yep. And it's any circumstance where you're doing very fiddly graphical calculations. What's going on up there? Oh, okay. Very fiddly graphics, computation like texture magic, or just brute force math, then the GPU will probably do better work for you. But you need to balance it against that. How often am I talking to it? With textures, there's a lot you can get away with in that regard. With compute, you have to be a lot more careful. Okay, well, that's going to stop it from working. That's not right. I know this got messed with. We messed with the entity manager a little bit ago. And clearly that has come home to roost. It's entity, looking for them by category, random by category. Well, that's why it's doing that. Because we're never adding them by category. And I feel like I didn't remove that, but I think I removed that. Yeah, that'll prevent it if we never go into add by category. So there should be an add entity internal. Let's make sure that we're not missing something here. Yeah, okay. Okay. Entity count is in the lower left, lower number. After about 3 seconds, 100 enemies spawn. That's what this little guy here does. Does it exactly once. So here's 3 to the 6th. I think this can get up to like 7,000-ish. Yeah, let's say 7,300 under this pattern. We can make more of them using various other bits of the code, but we're not gonna. But if we reduce it down to 3 to the 5th, it'll take upwards of 10 seconds for this to stick. Because we have to let some of them die off. What we're seeing is what I call a calamity case. That is, this strains the system as much as it possibly can. If the game doesn't crash in this state, or doesn't drop down to effectively less than a frame per second, then we're within our target area. Okay, so we're sitting at about 50 frames a second with 2,500 things whirling around on the screen. So full simulation speed. There is going to be some extra overhead. But let's add some of that overhead in here. What we've done, in particular, the way that they're spinning around like that is kind of expensive compared to other types of movement because we're doing a lot of calculation in that. But it's still working, just for giggles. Into 3, and after 3 seconds, do all of that. This will substantially reduce the number of entities on the screen, because the wait for 3 seconds still counts for the lifespan of everything that results there. So you'll see little starbursts of them up here. So now we're down to like 1,800 things, and we've got a nice healthy 60. Well, I said nice healthy 60, but we may have crashed there. We'll have to figure out, we'll have to keep an eye out for that kind of thing. I should have paused it. The rest of the code worked, and it was the simulation, so that was potentially a GPU issue. Well. This is part of the reason that we have to do the calculations ourselves, is each one of these is its own like little behavioral unit. So each one of them in sequence does a thing. These first 5 that multiply them are kind of one-off behaviors, but these alter the way it moves. And they are largely independent of each other. It's just that they get a slice of the movement speed of the entity. The more movement types, the less each one of them gets as far as the overall speed. The spiral in one, the one that creates the circling effect around the player, actually speeds it up. But because of the way it moves, it doesn't look like it's speeding up. So we're creating really complicated movement right now. It is moving in a hard zigzag pattern. And then it tries to orbit inward, and then it tries to move in a loop-de-loop. In that order. While trying to home in on one of the enemies, you can see. We're gonna let it sit for a moment. I want to see if the if this breakdown happens. But I'm pleased with that. So the farther end, when we're getting up towards like 10,000 plus entities, is well beyond calamity case, but we have managed to keep it at frames per second. Part of that is kind of a running gag. When we played Noida, the way I had it modded, my personal mod plus other stuff, our goal was the biggest, most destructive explosions we could create. I think and part of that process was it doesn't count if the game crashes. It's you've got to win, and the game has to survive the winning. So we ended up referring to it as minutes per frame. How long does it take the game to calculate a single frame update? If the game survives and it took 5 minutes for it to process that, that counted as a win. That counted as a hard win because the game still ran. I think the last time that happened, our best one was something like a quintillion damage, and it was largely just us watching the slowest PowerPoint presentation ever. So you're never expected to get to this point. But if through like the best lucky rolls ever, the player reaches a point where they have 2,500 projectiles in a cloud around them, you're going to win. And that's okay, because it's going to feel super cool when you do. And you may never get to experience that again. I like how there's a really intense blob in the middle. It's almost like a depth of a lake thing. But like, if you got to this, what are they going to do? It's unless they get above you in this particular circumstance. Okay. This is what we wanted. Well, this is not what we want to have happen. All right. We are in the middle of something. If we overloaded something. Just a moment. Okay, processes are running at a reasonable rate. GPU is not overtaxed at all. Process, it's in physics process, and we're going to do that. And we're going to let it go. Okay, so we're still getting the Godot physics update. Don't need you over here. We're going to go to our world state manager. Okay, so the world state is looking for the actual, like, Godot time passed. It sees that. It's going to get our game state object. We're going to check, is it paused? It is not. Physics done is not there. Okay, so we do our shader collision manager, and we're looking for this. Okay, we're never reaching our friend here. World steps done. Buffer, attach. Where are you at? On. We are not computing. Oh. Okay. This is false. And we're not computing. It's... no, I'm sorry. This is false. We're not doing anything. But over in world state, we're going to check for physics done. Physics is not done. Okay, we have an edge case there. I think this is more of a race condition. Under particular circumstances, it was possible that the world state and the physics state got out of sync. But we can correct this. If we are computing on the start step, then that's when we're going to process it. Otherwise, emphatically else. So we know computing is false and physics. We have an invoke. Hey there, Roman. Ooh, steps done message. Once more. So as might be apparent by what we're doing here, this is a pretty frequent occurrence. As in, the stream title, I feel pretty reliably is the thing we won't get done that day. On average, we sometimes do. It is a lot of mice. We're sitting at over 7,000 mice. So the reason they're moving out in such a weird wiggly pattern is the homing logic that the wind-up mice use has a minimum turn radius. So they can't just, like, perfect lock on. Then, after they try to do their perfect lock on, the resultant vector is oscillated like a metronome. At about, like, it's like every second is one side, or every half second, but it's back, forth, back, forth. And then it tries to force them to move in a tight little loop-de-loop. So since all of their targets are here, the homing logic is trying to pull them into the center. That's why we have this kind of darker mass here. Then on the outside, there's sort of like... they sort of break out of orbit now and again because of the sine wave and the loop-de-loop. Loop-de-loop, then sine wave, then loop-de-loop. So the darkened cluster is rippling out a little bit more right now. So the double loop is reaching the edges. So the player would not be dynamically changing these during gameplay. Oh. You should be able to find the others, Roman. I'll have to see. Okay, we're still in a crashed state. Look for world step done. We're gonna look for here. We're not paused. Physics is not done. Okay, so we're looking for game start step. Okay, well that's just downright weird then. Did we straight up break Godot? GPU is not overtaxed. Isn't really taxed at all, so it's not that we're waiting on the shader. But we're never getting into there. Oh, well. Derp. We are not computing. We do our physics update. Base world state. We invoke physics done. Then base world state. Game seems to be flowing. We are getting our physics done. Should get a delta then. We go through our process here. Which part? It is. One world start step for each entity. Oh no, it's in the entity when we get world time passed. So something is definitely having problems. I mean, our code's having problems. Okay, we are processing the message. Hey, Barack. Welcome. Yep, this is Godot almost exclusively in C#. As little as possible is happening in the Godot side. Physics process, base world state. We go into each entity. Send the message to health, send the message to behavior. We're going to look at the entity and we're going to look at our proposed movement. No proposed movement. This is which entity? No proposed movement. None. I haven't looped back around to implementing my own animations we are using Godot for visuals still. There was a period where we were doing the visuals in shaders, but I would need to find a way where I can do that cleanly. It is possible for us to revisit a multi-mesh for it. Right now, we're trying to get collision to work. Definition. So this is where we iterate over each one of the behaviors to find out what kind of movement we're doing. We should not be getting 0 this frequently. Okay, for behaviors. Yes, Brock. It's... So. Come on now. Get back to you in a moment. We currently have 3,900 things on screen. I wish I could do 39,000 with this kind of performance. Our visual frames per second are slowing down. There is something going wrong here. You can see the animations very slowly happening, but our frames per second is plummeting. Oh, okay. Well, this might help us short-circuit the problem. Well, our debugging. So one of the fun things when you're doing like C, C++, doesn't matter, coding outside of GD script, outside of the Godot engine editor, is the Godot engine can detect Godot level errors better. Okay, so I was looking at a let's get our foot in the door kind of thing. And Godot is nice and nice in kind of a free open project. Unity, by the time when I was choosing this, Unity was had fully entered their Let's Be Corporate Evil arc. So I shall not patronize them. Or they shall not have my patronage. But for the most part, we're using this as effectively the baseline heartbeat of the engine as well as the baseline visuals. Could I do this in Unreal Engine? Yes, but that feels like I am like committing to constructing an entire industrial workshop when what I want is a workbench and a hammer. Other kits like Game Maker or something like that, yeah, that would be viable. I don't know that I would use Game Maker. All right, Godot engine, let's go. I don't know that I need to overload it like this to make the issue happen, but we're gonna try. I can't really speak to Game Maker, like, personally. All I've heard is that it's not necessarily... I don't know that it would be, would be another way. I hadn't heard that it was great for, like, performance-tight application. But I could be wrong on that. I get that feeling, Thrax. I definitely understand that. One thing that I will occasionally say repeatedly is, it's good enough. It's good enough. Because otherwise I can get bogged down in, but I want it to work slightly better. Ah, we got a nice little pattern going. All right, Godot engine, anything going wrong? No? Okay. Not yet. We are definitely noticeably slowed down right now. Oh, okay, here we go. There we are. That red number is not good. Item with the same key already exists. Where? Oh no. Okay. So this is what's going down right now. We are getting an entity added, and that entity has an ID. But our shader collider set is based around the idea of there not being duplicate IDs because our system should not allow it. Which could mean that our shader colliders aren't being cleaned up properly. It would require quite a few entities to have shown up because we need to get past the 20,000 mark. Okay, but that tells us where our problem is, and it's not shader related. Neat. I mean, I know a lot of good games have been made in Game Maker. It's... if a person is just getting started and wants to just learn, like, I want to make a very, very simple game, then really any of the engines will get you there. Once you've done that, or once you're a little more comfortable and want to move forward, understanding what the different engines are good at and what the overhead is, I would say is the next learning step. At the moment, Barack, quad tree would be a thing. Quad tree would be a thing that we should be checking on. But ultimately, the thing that we're doing with collision is we're handing it to the GPU and brute forcing it. We could optimize it, and that might be something that I do to further optimize, is say, here is, like, even if I just quadrant out the world a little bit, you know, this is like, this is within X of the player, and make that a box, and then maybe like a series of boxes around the player for things that might be further away. That could greatly reduce the amount of collision that happens, and we could have a very optimized set for that. Then we could also potentially run multiple of those shaders on like their own threads. We'll cross that bridge when we get one of them working. Okay, though. Quick break, and then back to it. And we're back. Yeah, Threx, I had actually tried Unity many years before starting this project. Just poked at it a bit. Really just kind of like proof of concept maze generation algorithms kind of thing. And one of the annoying elements of it was getting libraries into it. Like there was an odd little song and dance that you had to do to get them into the Unity engine. That and their mono compiler was like a whole version behind most of the time. And I want to be able to do some of the cool new stuff. Well, I want to be able to use features that have been released over the past year or more. Okay, so let's go look at our on collider remove. Oh. And you see the problem? What are my feelings about the Dino Cop game? I liked it. I really did. Would I have liked more to it? Yes. I would have liked to see the story play all the way out. Even if it got less happy. I would have liked to see the whole resolution to it. But I feel like the ending was solid. Mechanically, did I like that it wrapped up with a stealth segment for a while? No, they shouldn't have done that. There are too many games that do and now suddenly a completely disparate system that requires a different skill set. You shouldn't do that. Dino Cop is a detective investigation game. Investigation is the Steam tag that it took me too long to find, because detective games are like Phoenix Wright, often. Investigation games are... Sorry. Detective games are much more like TV dramas with detectives. Investigation games are much more like having a corkboard red string and a bunch of pictures and articles. The first one we played was called Scene Investigators some time ago. And after each session of playing that, one of the jokes was posting how many pages of notes I had written after that session. Because that one ran deep. Kung Fury is such a trip, Thrax. It is unabashedly its own thing. Which you have to appreciate when a media property doesn't seem to want to admit or is ashamed of what it is. Okay. But so when we add an entity, we say, hey, shader colliders, add this entity ID. And here's what happens when we remove a collider. See the problem? We never remove it from the set. We have a dictionary. We never pull it out of the dictionary. Which means once the IDs of the entity manager cycle, once we reach a point where we wrap back around. So when we add entity here, we are dequeuing an entity ID. We're popping it out of the queue here and we're assigning it. When we remove an entity, we need, where's the actual remove? There we go. When we remove the entity, we're pulling it out of the collection. Oh, where do we enqueue the ID? We should do that here. World start step. I'll remove the entity, go to definition. We add it. Okay. We really shouldn't do this here. We should do this in remove entity internal. Okay, so we are reusing the ID. So whenever we use an ID, we pull it out, we take the first one off the list. When we're done with an ID, when that entity is gone, we take its ID and we enqueue it. We put it at the end of the list. Once this list wrapped around, over here, when we removed an entity, we never took them out of the dictionary. So once it wrapped around and we're going to add an entity, we're just going to try to put it in the collection again. But that ID is still in there. It's not an uncommon programming error to do things like, why isn't it to find things like, why isn't it doing the thing? Why it's supposed to do the thing, and you look and it's because you never told it to do the thing. That's, you know, it doesn't happen because you didn't tell it to happen. I try to be careful. It still kind of creeps in now and again, but you need to avoid anthropomorphizing your programs. It is a series of instructions. It follows rules that exist for it, and it does what you tell it to. It does precisely what you tell it to. So if it's not doing it, it wants to do this. It's, did you tell it to do exactly that at exactly that time? Because if you didn't, it won't. There are idiosyncrasies to it, but you know. It's one of the big failings, or I'm sorry, it's one of the big lies that big tech companies are using right now to sell large language models, is they use words that presuppose or that assert that it already is. I think often it's like begs the question that the large language model is intelligent. They use terms like it thinks, it reasons, it understands, it's suggesting kind of stuff. It's not. There is an algorithm for that. There are dice rolls in that algorithm to shake things up, but it's not thinking. Yes. Those are those fuzzy things in there, like exactly when this happens is not under your control. That's what it's doing. But the thing that you told it to do was queue this up for garbage collection. Shader colliders dot collider dot entity dot ID. And this should totally work, even though I've touched two different body parts of the code. And I shouldn't be doing that. Turning too many dials at once, man. Okay, so it is also relevant that we do this. We want as many things being created at once to maximize to increase the pace at which the IDs will be consumed. Also, you get to see the turn radius when I don't mess with their movement. .25 visual frames per second. I'm not calculating this simulation frames per second, but we can get an idea of that. We're still getting a healthy amount of I'd say we're working at about half speed as far as the simulation right now. The world simulation is set to work at no more, it does not go any more frequently than 60 times a second. Even if the system is lagging so much that it takes like a minute for that next physics or world simulation step to happen, it will still only happen as if 1/60th of a second passes. If the game is running super fast and you're getting like 120 physics frames possible per second, it will delay doing another one until at least 1/60th of a second has passed. Okay. I thought we had caught this, but we're still in the same problem. Let's accelerate this further. Data collection. Where is it? Player objects. Spread 3. One, 2, 3. Yeah, that's potentially too many, but, you know. We've added some more. Three to the 8th, let's go. Oh, wow. Look at the game chug when each second. Technically, something interesting is about to happen. There can only be 20,000 entities in the world. I thought so. Okay, this lets the error happen very fast. It takes about 3 simulation seconds. It takes more than that in real world time. Close that. Play find that error. It's more fun we do it that way. See, there's less of a hitch in that the first 3 is not 3 every second. It doesn't split into 3 then. It's over the course of 1 second. At 3 different intervals, it will emit 1. So it's slightly less per unit time. There we go. Pause. Oh, okay, we got the other side of the problem. Queue empty. So when we remove an empty, we re-queue it. There is actually nothing about this that we need to worry in that regard. But we need to make sure that when we add an entity, we make sure. Extreme case, Thrax. This is a border case. You should never get to max entities. So our max entity should give us some buffer over what is possible. Internal. Okay, right here. Which school are you folks in? Do you prefer to have your curly braces after or on the same line as the condition or header? If we try to add something and there's too many, we just don't. I initially learned to code in C++, so there are a lot of coding conventions that from that period is what I used. Three to the 7th should be enough. All forth the mouse vortex. If I have to, I will do on the same line. Otherwise, I like to have them on subsequent lines, but it's not really a hard and fast thing. I only like them on the subsequent line to create a very firm padding between the header and the first line underneath it. Like there is a minimum of a line with a curly brace, and then the next line indented. Very clear marker. Okay, no, we do need to the 8th to cross the line. I almost universally use camel case. The only time I'll deviate from that is... Oh, we still have the error case. Or a variation of the error case. We'll have to see which it is. This pattern here, the predicate underscore, is again kind of from the era that I learned. I started coding as object oriented was becoming kind of the de facto pattern. And around that time, you had things like, if it is a global variable, it is G underscore, a letter denoting what kind of variable it is, and then the text of it. If it's a local, it would be L underscore, that kind of thing. So the name of the variable would be fully descriptive of what it was. Now I use this for, this is a private variable. It will be capital case if it is meant to be publicly accessible. The language enforces it with protected, private, public, that kind of thing. But within the code, at a glance, I can look at that and say, that is the internal variable. That's the one the internal code should be touching if I've got it. Yep. Buffer overflows and just essentially rollovers are things that are often not accounted for. You know, like I cast this variable into that type of variable, but I wasn't paying attention to the fact that this is an unsigned one that it's coming from. So when it's moved into this other format, there is the final bit that can make a difference. And suddenly you go from having a big positive number to a wildly negative number. Or even just with signed values in general, if you get too far on above, it will wrap around to negative. Crusader Kings 3 is one that does that. If your resource numbers get too high, they will roll over into negatives. And the systems in that game make that incredibly bad, almost unrecoverable. Okay, we run that in Godot again. Go. Yeah, about 6,500 per second is how many mice are generated. So it should be on the 4th tick that we hit an issue if it's going to happen. Interesting. Notice how there are way fewer mice here? It didn't fail on the Godot side. Yes, they are drawn on top of each other. Oh, Thrax, you mentioned the visual shaders. You see how there's a black outline around every creature? That's not actually there in the texture. That is a shader effect. Interesting. Why does it not do that in the C# side then? Yep. The first shader that I did actually was a shader to actually fully render and animate the sprites when I was trying to do a multi-mesh. So all of the animation and whatnot was done inside of the shader using like, you know, grid offsets kind of stuff. Might we come back to that? Yes. If it ends up that we've got everything working again, I might revisit the idea of using a multi-mesh. But there's just a lot of footwork that goes into that to make it work properly. Why did you explode last time but not this time? That's the most concerning type of error resolution, is when it doesn't seem like there's anything that did it. Like, nothing should have changed, but suddenly the error's not happening anymore. Other fun fact, last time we were doing messing with shaders a lot, we actually managed to blue screen our stream like 3 times. Luckily, the way I've got the stream set up is the stream can survive it. There's just a period of you can't see anything. Okay, well, it's doing what it's supposed to. I feel like what could have happened is that the C# side did not fully compile in the new changes. Okay. The 20,000 limit is arbitrary, by the way. I have just declared that to be so because it takes so much to get to that point. Again, so 3 to the 8th lets us see the problem. This is 3 to the 7th each second, each simulation second. So one of the things that's happening with the split behavior there is whenever a projectile splits, there is one going the same direction that it was, one rotated 45 degrees left, and one 45 degrees right. So you will get overlap when they spawn, because the first one emits them left and right. Then each of those splits in 3 again. And again, and again. Okay, this is 10 visual frames per second with 19,000 things. We are operating at a simulation speed at maybe like 1/5 to maybe 1/10. Okay. Here's our most expensive movement type. Okay. Let's scale it back from 3 to the 7th. 3 to the 7th gets there, but slower. Yeah, it's like Vampire Survivors is our general goal. But we're looking at having very modular weapons instead of just... Okay, we broke it. I think. Yeah, we broke it. Where did we break it? Okay, it lands there. It can land here. We are using Delta time, Barack. So the animations happen independently of the world simulation. Effectively, Godot handles the rendering right now. So as fast as the FPS will allow it, the animation will go. So you can see the frame ticks are still happening. It's about once a second-ish that the animations play, but we're going at 10 frames per second or so. So you say we're waiting for Godot. Womp womp. Okay, well, that means we run it on the Godot editor. And see if it tells us what error we were encountering. So, as long as the player would hold still during this, there's not much that would prevent you from losing, that would prevent you from winning. Okay, this is holding at about 73, which is weird. To the 7th. We've tried a lot of different types of music on the channel, Thrax, but like kind of piano and strings and the like has been, I think, the best. Okay, we hit the error case. What's wrong this time, Godot? Duplicate key. Entity added message, we're still getting duplicates. Okay. But how? Entity added flows steadily, but entity added can happen faster than entity removed. I thought we were only removing when we get to internal. There's add internal, where we are dequeuing. We get to here, we have an identifier. So we're saying here it is. And remove entity internal is where we dequeue it. And the entity will call out that it's being removed. And that will relay up. Tricky, tricky. So the sequence of events is that each time, each world simulation second, we are emitting a projectile, and each of those projectiles goes through its behavior chain. Part of that chain is that an entity will split, causing two more to be added. each of those immediately comes into existence. Yup. It immediately pops into existence. It takes one of the keys. So we take that key there, we dequeue it. We add the entity into our own collection. We add it into the secondary collection. We set it active, and then we emit the entity added with that entity. When we remove it, we're saying, does it contain this key? If it does, we're going to call entities remove. Let's step through this here. It'll take about 10 seconds, and that will go away, and it will trigger this chain of logic. Or longer than that. I can't remember what I set them to. Okay, so we're removing it from the collection. Is remove entity. Oh. No, that's fine. Well, there's our problem. So you see how just some of those mice disappeared? And you see how this didn't happen? It's important that this happens. Okay, on collider remove, so then we need to go to close out all of that, down to you. On entity remove, then it will invoke remove. I could reduce their lifespan, but part of the reason that they last so long is to get the have a whole bunch of things going event. Now, I could change it such that I have a, split into 100 modifier. Okay, it's never getting an entity remove. Entity added. Yes. Like, this has to be happening. It's a better place to look for it. Okay, we're going to open up entity. Going to go to invoke remove. We're tracing backwards. We've been steadily shifting over to a very a heavily decoupled event architecture. And I expect there are some frayed wires still. Entity visual sprite has it. That's the shadow of the entity. It's the room knowing that it's removed. Okay, that will prevent it from working. Update entity data. Oh. Okay. Now, earlier I mentioned a very common error and a way of thinking about it, and that's that the code only does what you have instructed it to do. If the list of instructions says do this, it does that. If it says if it does not say that, it won't do that. Now, you might not know the intricacies of the instruction you gave it, but that's what it does. These are very important. They subscribe to the events. You see these numbers that say how many places in code are calling them and how they're 0? That's going to make it not work. Oh, boy. Ah. On a related note, that kind of functionality is one of the things I like about using Visual Studio and other robust IDEs, is that kind of like, you're not using this code anywhere. You're not using this variable anywhere in your solution. That's good to know, because otherwise you might be making further assumptions about it and you would have to search for the reason why, as opposed to being able to look there and say, I'm not calling that anywhere. So we have to wait until some things start going away. These in particular will be the first victims. We're doing it this way because this also ensures that the problem will happen very quickly. Comparatively quickly, because we have used up every ID for an entity. Now, if they actually make it so that a multi-mesh supports Y sorting. Okay, our first removals have happened. Shader Collider is invoking removal. Ensures the problem will happen very quickly, yes. Oh, a new problem. Oh, no, it just hiccuped. I mean, our garbage collection has got to be brutal right now. The physics system doesn't have, like, as much caching. Okay, now we run it in the Godot side to see if there's any accumulation of fancy new errors. Okay, so this time we're going to get to 20,000, and then we're going to cut all the way back on the generation of them to make it easier for them to die off. It should hit 20,000 soon because this way... Yep, there we go. Now we're only going to be attempting to create one per unit time, so there is less of an overhead of the projectiles trying to, or at least the spawner trying to emit projectiles that are trying to create more. Technically, I would have wanted to do that earlier before it hit 20,000, because now that I think about it, that was meaningless. But, you know, any time now. No errors accumulating. Gameplay, so I was asking as far as like what kind of game are we looking at? It is going to be a survivor style game, you know, piles o' monsters coming after you. Fire wildly. Okay, no error there. No error there. They have faded out. Okay. It's just we have a big, ugly bit of garbage collection to do during that. We need to have caching of the all of the little bits, so there are fewer objects being released for garbage collection. There's going to be fiddly elements to that. but it is doable. It is doable. Okay, let me back. Okay. We have been quite thoroughly derailed. All right, let me checking something. Okay, atomic. There's atomic add and atomic min, max, and exchange. That's what we need. Okay. I think it's that. Did I leave that open? Yeah. To the thing and how much. Okay. This is relevant. So we're going to pick an arbitrary number of collisions that are maximum possible for a given entity. So this entity can only run into X things per physics frame. If we're generous and we say 20 things, that would primarily only occur for explosions. Could that be a problem later? Yes, but that's a value we can fiddle with. We could even use some more local invocation stuff. Anyway. Is that here? Go over here. There's a problem with the GLSL. Oh, can I do this? Line 40, which it thinks is this line. Okay. We can solve that. Back over here. There we go. On game start step in here, down here, run this. Result, which is incorrect. We are getting numbers. Okay. On. That's why. I was casting it to the wrong value type. Once more. Zero, 1, and 2 don't have anything in them. And there are several with zeros still. GLSL, compute shaders. Zero to less than. Implies that it's zero driven. Okay. Why would 0, 1, and 2 not be getting set? It should be This data. Adding 1 to the index value, but the implication here is that the first 3 indices don't get anything. But the fact that it's the 4th index that actually gets values doesn't line up in this regard. So when we cast it back here, still 0, 1, and 2. The first 3 are blank. And then an arbitrary one in the middle. I don't see how 0, 1, and 2 could avoid being processed. And test gate is 1. If I actually commit that. Okay. We're waiting an extra frame. Wow, that made it worse. That made it worse. You reveal the Godot editor with the shader editor open. If it was already open, tab away and then tab back. And it seems to realize, oh, I should try to recalculate the shader if it's changed. Okay, no immediately apparent errors. So it is possible that this is just off kilter. But how can we fix that? I'll put test bytes. Series of uints and data. Implies that the first block is not coming in correctly. Local sizes in chunks of 20. How could we get here without... Because the first thing should be 0, 0, 0 here. And then 0. So our index should be 0. Then we're going to iterate through the data size, which is the whole length of the test data. Data.data.length, yes. It's not like that goes away. And we're not doing any other checks in here. Oh. It's only if this would be true. Be that silly? I mean, I'm fine with it being that silly as long as I found out where the silly is. Okay. Okay. Once again, it follows the instructions. You know, the result is the compiled instructions. If the instructions include the wrong thing compared to what you think is going to happen, then you'll get the wrong thing. Only if a collision would be detected would it go through. Now, we're not checking for active, so all of the values otherwise are 0. Which means that they're all on top of each other, so they all collide. So we're going to do another one. if collider.data index .active or collidable. Check it on the Godot side. Okay, only if it's collidable will we do this. So we're actually going to move you here again. Okay, so at the start moment, the first things to exist should be the door, the player, and the spawner blob. But we're getting a 0 right away. Nothing. Okay. Oh, well. And that is a Boolean. So that should work. Make sure the shader was ready to go before I executed it. There we go. So we run the player, which is almost universally what 0 is going to be. And it's going to see two other things, the spawner blob and the door. So then the next one is going to see two other things, except that it won't look at the player. The player has already been paired with the first thing. So it will look at one, and the third thing won't look at anything because all permutations are now covered. Yay. Okay, so this is the basic check, is first, are we in bounds? And if we're in bounds, is this something that can collide? If it can't collide, we don't care, skip it. This is what happens when an entity is removed or otherwise prevented from colliding, like it's got iframes or something like that. That can cause it to be non-collidable. Then we're going to check all the other ones. If one of the other ones is collidable, then we'll do a distance check, and we are going to move this logic into essentially a switch based on the shape. Shape 0 is don't do anything with this, skip it, there's a problem in the config. Shape 1 is a circle, and in a circle, dimension 1 is the radius. And, you know, with a square, it would be height/width, pairing. In a capsule, and in a square or a rectangle, there is also a rotation. In a capsule, it's radius and length, so that you can determine like how long the whole thing is, and then if you remove the diameter of the resultant circle, that gives you the size of the rectangle that runs between the center of each circle. And then again, there would be rotation, but we're not touching rotation just yet. We're starting with circles because circles are easy. Okay, so we found it. They are both collidable. And so it's going to be this one. Actually, that is a subsequent check. Cool. This is a uint mask uint category. Turn mask bitwise and category can we get away with that? No. Okay. So we're going to have two collision checks. One for index to I and the other for I to index. Okay. Check a couple of things here. Buttons. And one more. Okay, quick break, and then we're back to it. Yes. And this one goes here, and be right back. And we're back. We'll change that to can collide. Then there are so many permutations we're going to be dealing with here. But this should still be viable. Void. Uint from uint to source target if would like to do a check internally, but okay, they're both collidable. I think this is still viable. I could move this into a collision check logic. Because this one short circuits a whole bunch of things at once. This one is only relevant to this first check, so we're probably just going to do this. If can collide. That would be the source mask to the target mask. Targfet. Okay, so if they can collide, you could just wrap that, do the same thing. If they can collide, then we're going to do this. So we have a switch here. We do switch. We're going to run with the assumption that switch is actually slower than cascading if often, because you still have to check each case on the way down in a lot of switches. There are permutations to this. Going to just do a return here. Bool collided is equal to false. Source target. Again, we'll have to come up with a good pattern for this. Because every shape creates permutations against every other shape. So if I have circles and squares, I need to have circle to circle, square to square, and circle to square. And so on. Source, target. Check from index to I. Say if move that up here. Test data, index, and 1. Come here. Being a nuisance again, Sky, are you? Hey, we're gonna look over here. Vision check has no matching. Vision check has a source to a target and is a Boolean. We have a source and a target. Both are uint values here. I think that might just be part of a multi-stage error. First one is on 36. both things are collidable, which is a Boolean. Left-hand operand of type restrict global bool. Of type constant float. Okay, there is something about the return here. Because this should be a Boolean, so we should be getting a Boolean here. It's just... Okay, we needed that wrapper here. And on... Still on 36, which is kind of 37 here. It still considers these... I do this in this syntax. Do I need to do this in this order? Forgot which era we're living in here. Yep. I will explain this in a moment for those that haven't done C-like structures. I was invoking collision check in this code, but collision check was defined after void main was defined. So when trying to compile it, it would validate this and encounter this symbol, which doesn't exist yet. So we shouldn't need this. Yep. Hide this. This. Good. Looks cleaner that way. Distance from this is equal to that plus that. And then in the manager here, I in result if I is greater than 0, break here. These don't actually collide because they're a different type. We should have gotten something, though. X is equal to 0. Make sure that we're not just breaking wrong on it. Because the bullet can't collide with the player. The player can't collide with the bullet. But in theory, that should have been the case because this is actually an enemy. That's not an enemy. Okay, so we never have... We're never having greater than 0. Let's... If collision check, we increment the test data index by 1. So do collision check, and collision check says if I can collide between the mask and the category, we go into the collision manager and go here again. Okay, so nothing got added there. This. Shader colliders, there are 3 of them right now. One as an entity, this is a player. Category 1 and a collision. Second one is the shader is a door which only collides with the player. Okay, that's definitely should be collision there. Okay, so result has nothing. That's okay at the moment. And we're looking for our shader colliders. So there's our player. This should be a bullet. Should be a visual key. Yeah, wind up mouse. So this is a bullet, which has a mask. Vision mask of 4, and it is a category 2. Through category 4. Okay, so this is an enemy. It collides with category player. We should have gotten collisions by now. Okay, our shader collider is still circle. Values. Radius of 1. Glider. Open. Glider circle, radius 8. It's not coming through. Shape is 1. Radius is 8. Double check spelling. Which is in collision, shader collider. Here. Shader collider circle. Sound constructor. So then we go with this, and we're looking for our shader colliders again. These are now shader collider circles, and their radius is still wrong. Because I'm not duplicating them properly. It shouldn't matter because their dimension should be correct here. But the radius is not being updated in the duplicate function. Public override. Duplicate. Yes, hello, Sky. Hello. Cheater, collider, circle. Duplicate is equal to base.duplicate as a shader collider circle. Duplicate radius is equal to radius. Yep, yeah, I acknowledge you. I do. I do. There's definitely still food in your dish, sir. Sure, your chin is all clean. He likes his chin scratched, which is an opportunity to make sure that he's not got, you know, food particle buildup in his fur. There you go. There you go. Turn the duplicate. Run it again. We're going to see if we can get a collision here. No collision recorded. This shader colliders, they are circles. Radius isn't coming through. So one possibility is that they're not precisely striking the target because of the movement. Oh, further stuff. This is some of the nuance of the JSON here. Get, set. The JSON parsing by default only sees properties. Should definitely be able to collide, but they're not. Oh, there we go. Okay, yeah, the spawner is a different type of entity. Or at least it's recorded differently. Excellent. Right there, this has one collision. And bear in mind, we're doing 20,000 iterations on that each time. So what we're going to end up doing here is that the result is going to be like one part of its length is going to be one for every possible entity. We can fiddle with this more, though. So one possibility is 1 in length for every possible entity, plus for every possible entity an additional length for every possible collision that it could have, which would result in a one where it would be the first value is the count of collisions for that entity. Then the next max count of collisions values are the indices of the things that entity ran into. Which means iterating over it is saying, okay, the 0 index is the first one, plus x is the end of its own. So it would be plus x plus 1 each time. Kind of. Alternately, we could have 2 more collections for output, but that starts getting us into shaky territory. Instead, we could have multiple pieces to a single structure that we pass in. But that's not going to work quite right because we want to be able to have an arbitrary length coming in, and the structure would remove that. But more buffers is technically more expensive because we have to retrieve them each time. Okay, so it would effectively be zero is equal to the count, and then 1 through okay, so max count is going to be, index plus max count is going to be the index of the last one. So index plus max count plus 1. And each entity accounts for 1 plus max collisions values. So it is uint in size times, we're going to do 1 plus 20. So it is enormous here. And we're not just going to iterate over I. I don't like messing with them. I often forget to do a commit when I should. But the goal here is to essentially put down save points, so if something goes terribly wrong, I can retreat. Uint location. This is the count index is equal to index times 1 plus, I think it was 20 that I put there, right? Yeah. Okay, we are going to atomic add it so we know what the prior one was. It's equal to this. We're fully spelling this out. We could condense it down, but we're not yet. Collision index is equal to I. Okay, this should create a listing of which things it collided with. So then we go into our collision check here. All right, for moment I is equal to 0, I is less than length I plus equals 1 plus 20 for now. Okay, so this is iterating over the result span here. If result I is greater than 0, then we're going to iterate over that. And j is equal to I plus 1 is equal to, we're going to start with 0, j 1 is less than or equal to 1 plus 20. We'll replace that with a value here. Fine, fine, fine. Yay. 0 collided with 76, though. That shouldn't be right. Index of the collider data, so 0 should be 0 is its count index. Let's index 0 over and over, though. Would be 21, would it? Because 20 would be... I think it would be +1 after that. No, that's correct, because it's 1 after the count index that we're going, and that's where the 21 comes from. Increment the count index by 1. Oh, but count index could be getting messed with already. No, this is local. No, okay. This can return it, though. Check for compilation. That should be fine. Here, and we're going to break on that. Getting there. Vision, so we will change this so that we can get the value in there properly. It's 20 is less than length I plus equals 1. I times 1 plus 20. Same thing. item 5. So if we look at result, item 5 collided with item 1. I'm sorry, collider 5 with collider 1. Here, shader colliders, collider 5. Its entity is a monster, I believe. No, actually, it would have to be a bullet. Visual key, yep. And then collided with 1. Doesn't really scan. That's the door, though. That would be up there. So that's not correct. Five wouldn't be able to collide with 1 in that way, though, either. Means our data set is flawed. Our output is flawed. So I times 21 is the count index. That's still correct, though. It'd be 21. It'd be 0 through 20. The first one is the count, and then the next 20. That should be correct. Atomic add. Flashbang. Put there, and then we return it. Immediately before, we don't -1. It's what it was. But doop doop doo. Wouldn't have made sense that it was 2 either. That is player again. Yeah, 0 has 71. 0 shouldn't have anything in it. 0 is the player value. Oh, no. 1, the collision check isn't correct. Because right now we're ORing them together, we're ending them together, which just means they have to overlap. They can collide with each other. So when we do our can collide, it's not greater than 0. It's that's still not right. We need that the category contains mask. They line up the same way, though. That should still only work correctly. Yeah. No, we should be good there. So we get a collision check. It is true. We could offset this entirely and just have them start in blocks. So if we did index to find the collision index, so we'll use index here. Data size is also not correct. We need collider data here. The collision index is whatever is there. Plus data size gives us the offset plus collision index. Okay, that should be cleaner. Entity manager dot max entities. So that's going through for max entities in there, and we're finding out if any of them collided. If the result for that is greater than 0, then we're going to find the relevant ones. So we're going to start here. Plus I times 20. for j is equal to 0, j is less than 20. J plus plus. If being helpful, editor. If result this is result of max entities here. So that's where we start. Plus I times 20. Plus j is greater than 0. All right, so past the end of the list of entity counts, in chunks of 20, we're going to go through each of those and find them. And j is less than result I, and j is less than 20. Only need to iterate over how many there are. Result I is equal to 0. This will be relevant later. Check. Okay. $1,000, 3, 1,000, and those guy. Okay, we are never getting collisions. Alt. That run, and we are just gonna flood the area with them to kind of ensure that there are collisions happening. Okay, I think our math is just going to be off for this, so let's see here. I think this will be a good wrap-up point. I need to poke at this a little bit more. So, well, as is tradition, we did not get through what the title implies we were going to try to get through, but often we fix or adjust something that would lead to the thing that the title was about. So we are at the point where we are trying to get the collision information as smoothly as possible. there are going to be ways for us to clean this up further. But we'll have to see how we get there. Lots of ways we can go about this, but again, we're being tricky. All right, folks, I hope you had a good time watching with us today. If you like what you saw and would like to see more, remember to like, follow, comment, subscribe, all that good stuff. Those buttons are generally positive. I'd appreciate it if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means like memberships and subscriptions, as well as other options available through the link tree that can be found in my video descriptions and bio. With that said, though, I hope the rest of your day is good, and I will see you next time.